Hey guys, can y'all hear me? Hey guys, how's my audio? We have 0 people, guys. Let's go. Alright, it's one of those emergency Wednesday streams, guys. I got my Tesla Coil in the back. It's just right here. Check if everything's working. Okay, there's this thingy. Let's see here. Okay, so we got one person in the chat. Let's go. Hopefully it's not just me. But either way, it's all good. I use this to force myself to continue with my free energy mumbo jumbo. Let's play this. One person in the chat. Let's go. Hopefully it's not just me. But either way, it's all good. I use this to force myself to. All right. Okay, epic. Okay, 297 BDA is in the house. Let's go. Your first person in the house. Let's chatting. We have 2 people now. Okay, epic stuff. So I think just me and you, or it might be someone else as well. Okay, I just finished my apple. I was rushing. I usually get a fruit just before this. Okay, and let's see. Okay, and also in Leo. Let's see. Okay, we got this right here. And guys, here's the threadcast on in Leo. If you guys figure it out, I'll get you upvotes, and yeah, and all your comments will be there forever. It's not like YouTube or Rumble or anything. I'll post on Rumble. Okay, and alright guys, we are good to go. Yeah, if you can figure this out, I'll give you an upvote. You earn crypto, earn Hive. Alright, so let's check out what we have. So again, I have a bunch of links to look at, but I also have my Tesla Coil on the back right here. So a bunch of links, basically whatever I haven't covered or missed from my last stream, I go there. And if anyone has questions, math related, science related, technical stuff related, I'll get on it. Alright guys, so I have 2 people in the chat. So I could show you my thingy. I'm gonna actually test out the Tesla Coil right now. I tried to do it on Saturday. I just didn't know how to figure it out. Okay, where's my thingy there? Okay, it's behind me there. Okay, there's the Tesla Coil. I'll bring it up. So yeah guys, we're gonna do lives. If anyone understands how Tesla Coils work, and we'll do, first of all, we'll do a tutorial, and I'll try to figure out how in the world it works. Make this a bit smaller, maybe. 1 time smaller. Okay, that should be fine. Alright, and this is good to go. Okay. Alright guys, so it's still just me and you. Okay, so if you have any questions, I have a Tesla Coil right here. I'll make it, I can make the thingy bigger. So there is the Tesla Coil. I paid 200 bucks for this. Alright. You heard about what they found under Giza? Yeah, I saw that in the news. I didn't actually look into it, but I noticed that Alex Jones banned video is posting about free energy under the pyramids. So it's very interesting. Actually, we'll do a look at it right now. Then I'll do a tutorial on the Tesla Coil. Then we're gonna plug it in and see what happens. Because I tried to plug it in, I didn't know what was going on. And they also gave me the wrong, they gave me a European coil, I mean a European power cord. So I gotta order an adapter as well, unless I have one in my room. Okay, so I'm gonna check the pyramids of Giza. We'll go to band.video. Let's go to band.video. They're talking about Giza. I think this was Alex Jones Giza. Where's the Giza? Yeah, the Great Pyramid Free Energy Truth Bomb. Let's go. We're in this. Okay, this was the Tesla Coils underneath. Interesting. Let's check these. Hopefully it's not copyright. How do I make it sideways? Like, does anyone not know how to realize people watch? They don't like. I have a giant screen. I can't make this full screen. It covers everything. I want to make it just sideways. Okay, so I'll make it bigger. Like I can't even do that. Okay, so what I'll do is I'll go to BitChute, and then go to band.video. It's like I can't even watch it on their own thingy. Okay, band.video. Let's see, band.video. Okay, it's like how do I find band.video on BitChute? Like this is unreal. Band.video BitChute. Just like find it. What's the issue? Why is everything so hard? Band video. Okay, I literally saw it from there. So we're not leaving until we figure out how do we get there. Oh, that was it. Oh, band videos. This is it. Band videos. No. could have sworn. Yeah, band.video. It's not even the first one. Okay, band.video videos. Just so we could play it full. Okay, let's try to power through, guys. Let's see. Where's the Giza Pyramid? These guys post. No, okay, there it is. Okay. So what? Basically, just so I can have this thingy sideways. It's gonna get bigger.
Dr. Corrado Malanga, Polo, Professor Filippo Biondi, Dr. Armando Me, and Professor Corrado Malanga announced the detection of extensive subterranean anomalies beneath the Pyramid of Khafre, utilizing SAR technology or synthetic aperture radar in collaboration with Capella Space. The team identified chambers, corridors, and vertical shafts extending at least 1 kilometer deep or 3,280 feet deep, with dimensions mirroring the pyramid scale.
Can advanced technology be lost and rediscovered centuries later? Is it possible?
Interesting. I don't have time to watch the whole thing. Yeah, that's pretty interesting. Let's see what the mainstream says. Let's see. Giza Underground found. Let's see what this was. And then we'll ask Grok. This is it's pretty interesting. Over a hidden city. Experts clash. Let's see what Snopes says. Let's see what Snopes says. Okay, what is, just check what, claims of new ancient structures discovered are greatly overstated. Pathways 8, vertical, deep 648. What is the actual reason? What is the Substack? I mean, this Snopes says. Yeah, this is Christopher Dung, the Giza Power Plant, 1998, and so on. Okay, so, okay, anyways, Snopes is the usual. It's like Snopes has no credibility, but it's like, but the thing is, Alex Jones has half credibility, news secrets, but I just want to see what the actual evidence is. I don't want to see all this mumbo jumbo. Okay, where's the, let's go to see the paper. Appears to be vertical shafts, 8 vertical aligned. Evening online of the revisionist. Let's go. Yeah, I saw your message about Morgan Reynolds, guys. Morgan Reynolds, he's in a hospital apparently right now, and yeah, prayers up for Morgan Reynolds. Okay. All right, guys. Anyways, I'll try to power through. I have my testicle in the back. I'm gonna figure it out. And so yeah, I just want to see this. Team claimed they discovered 8 cylinders like this. This is the scan of shafts underneath. Interesting. All right, and there's a team right there. We'll see. I'll just do a Giza pyramids coils. Let's see if it looks like coils. Is it actually like coils? New discoveries. Yeah, so it looks like, okay, that was the paper. I'll see the paper. Okay, this one's pretty interesting. Okay. So anyways, possible there, but then the Snopes is going after it. So and Snopes is the usual. So anyways, I haven't looked at this too much. Claimed discovered 8 cylinder shaped. Okay, so anyways, so they got Tesla coils under the pyramid, possibly, and but they get these weird structures. So again, if they can provide more than this, again, this is what is the evidence. So basically, this is a theory. This is the evidence. This is okay. What in the world is this? And does that mean this? I don't know. It doesn't seem like it seems to be too big of a, like, I don't know why they just can't dig underneath and see something like this, or some sort of better imagery than this. But anyways, so this is the evidence, and then the question is, what in the world is this? And then these guys saying it's this, but again, I need to see more stuff. But nonetheless, I have a testicle in the back, and we'll figure it out right now. And I have a bunch of links that I have over here, and we'll go through them all. But the key ones I want to show, I'm going to go quickly how the Tesla coil works, because I need to figure out how it works. How Tesla coil works. Also open up my x.com. Again, this is an emergency live stream. We have 6 people in the show. Let's go. More than our starting off 0 at the beginning. All right, I'm gonna go Grok. I have a history of this one here, because I was trying to get the testicle to work, and it wasn't working. Testicle comparison for experiments. Where's the Hutchinson effect? This one is not the one here. Was this the one? Oh yeah, this was the Hutchinson effect, and then went all through here, and then I asked it for stuff like here, the specs. Anyways, So I'm gonna open up my stuff. Let me just get up to speed, and then we'll get through this. So again, we got our 2-hour emergency live stream Tesla Coil. Okay, so here's a Tesla Coil that finally arrived. This one right here. I have it behind me as well, and soon I'll try to figure out how it works, and if anyone can help, because I tried to figure it out Saturday, I couldn't do it. Well, it's because I was actually trying to show my nephews how to run it, but then it was too hectic. Okay, so this is what it is. I got it comes with a bunch of this stuff. Let's open this up bigger. It comes with this stuff and this, and then the power cord. This one is a European one. I didn't even check the European size. I gotta get an adapter. I'll do that quickly as we go through stuff. Anyways, so there's Tesla Coil. So then the question is, how does Tesla Coil work? How Tesla Coil works right now. I just don't want to get a copyright strike, but we'll see. What this was looked like a pretty good video.
Nikola Tesla is probably one of the most appreciated
Okay, I hate this
electronics because of the talk to you and all. Now let's see how understanding these two physical phenomena. It is easy to assume that we could apply current.
Okay, anyways, I don't like background music because it might get a copyright strike. Let's see how Tesla Coil works. How do Tesla Coil musical ones work? Complete explanation. Okay, this guy might be decent.
Hey guys, take a look at this. You probably didn't know, but I have a side of power electronics. More than 15 years ago, I was there in the 4 coils of the world. It was so in this video we are going to the widest challenging Tesla coil that was used in the carnival party in Brazil. I used 2 diesel generators to power this machine, and the biggest challenge
29.7 BDA. How's Hutchinson doing? Yeah, he's doing well. He's back home. Apparently just still has some like hard walking because of his he had a bladder stone. So again, he did not have a heart attack. He just fainted. He had a bladder stone, like kidney stone, and yeah, he still has trouble walking and so on. But he's back home, and he's also on Facebook again. So if you haven't seen my post yesterday, I'll go scroll down. So here's the post. So John Hutchinson, he still can't find it. Still can't access his old Facebook. So he has created a new one, and give him a follow. And he posted on my Facebook. Okay, so give John a follow right here. He has some very interesting posts and so on. So there's 58 friends. You could go and do a friend request, ask him how he's doing. And yeah, he posted on mine. He said EVO says hi. So that's pretty epic. There's Mr. EVO. And let's go. And I said, hi, Mr. EVO and Mr. John. Okay, and then John says, great fun. Okay, so John's doing well. Yeah, he could be better, but he's doing well. And also Morgan Reynolds, for those who don't know, he filed a key tam case against NIST. And yeah, for the airliner fraud on 9/11. And again, he's also in the hospital. I'm going to read this out right here. So for Norman 9/11 revisionist, hi all, please keep Dr. Morgan Reynolds in your thoughts and prayers. Dr. Morgan Reynolds let me know that he's struggling with an upset stomach since Friday. Yesterday he let me know that he saw his physician and things went rather well with blood tests and x-ray. The latter showed excess gas. He prescribed an over-the-counter med. The 2 biggest problems remained was a weak voice and and in what amounts to hiccups about every 10 to 12 seconds. Then early this morning, John Harold, Dr. Reynolds' IT guy, let me know that Dr. Reynolds now in the ER and will be going into surgery tomorrow. Please keep him in your prayers that he gets through this speed bump. Yeah. So definitely keep him in your prayers, guys. Okay. So anyways, there's Tesla Coil. We're going to ask him how it works and see what this guy
there
says.
was the grounding. So in this video, we are going to the whiteboard and we are going to learn how a modern Tesla coil works, how all this power electronic stuff behaves, how a Tesla coil is related to the problem of...
Also, a question is, yeah, how is my audio relative to the audio? Is audio much higher or is it the same? I'm going to lower this a tiny bit. Okay, I think this is fine.
Impedance matching, and in the end, we are going to see how a PFC I made worked, running for...
I'm going to lower this a bit. Let's see.
4 parallel boosts for...
I just want to adjust the audio so it's equal. Okay, so that we have equal stuff.
Phases, translating the mains power to a 600 volt bus to power the Tesla coil inverter while delivering
Okay, so we're just going to talk about
15,000 watts. This is a very special vector made of a copper wire. We have a wire of aluminum, we have this toroidal shape here that's made of aluminum tube. We have the secondary coil, that's a long inductor made of a copper wire. We have in green the primary winding, primary coil. So these we call top load, secondary, primary. And what is the big end result of a Tesla?
Okay, yeah, so basically I have, right now I have a big giant aluminum donut right here. So that'll be the top load. Then there's a coil right here, that, I guess that's secondary. It's basically infinite amount of wires, a wire that's spinning around, literally infinitely tiny and moving around in a circle. Okay, audio good, let's go. I just want to make sure it's the same, my audio and the audio of the video. So that, don't need to adjust the volume. Okay, and then where's the other coil? There's a bunch of other stuff underneath. There's a small coil inside. So primary, where's the primary? Is that how do you know what primary is? Okay, it's because this is a giant one. So there's probably a second, a primary one underneath. Let's see what else is happening.
Tesla coil, the objective of the Tesla coil is to generate very big sparks. So the output, the goal of the Tesla coil is to generate very high output sparks. Sometimes the sparks touch the ground and it becomes very thick with a higher brightness because...
Okay, I'm gonna go back to this one. Looks like you got one. You got a good one. Yeah, I got a powerful one according to Grok AI. Told me to get the most powerful one for my application. Because my goal is to do Hudson effect on a little tiny penny. So basically scaled up everything down, but still a lot of power. And I'll try to run it in this live stream. But I just want to figure out how does science of Tesla coils, how does it work? How does Tesla coils work? Let's see if this is a short one.
Think of all the cool coils.
I see when I put music in the background. When they do that, it's kind of like easy for copyright strikes to detect.
In the world. There's Tesla coils, and yeah, that's pretty much it. Most coils are just kind of there. We lucked out making this next segment about Tesla coils.
This is called a Tesla coil. It's named after Nikola Tesla. If that name sounds familiar, it's because I just said it twice. But it's also because he's an engineer and an inventor. He created the first alternating current motor. Oh yeah, and there's a car named after him. Maybe after a couple more segments, they'll name something really fun after me, like an ice cream machine. Hi, I am Electric Cat.
Just give me the answers. Why is everybody doing this?
When you use a toaster oven at home to toast up your bagel, your appliance runs around 120 volts. Small coils, like this one, can put out around 100,000 volts, while larger coils can produce over 1,000,000 volts. The high voltage charges generated by the coil create strong electric fields that excite the gas in a fluorescent tube.
Okay, this is not explaining anything. I'm gonna go back to that. Historical deep dive. Everybody's got... Okay, I'm gonna go back to that original video. This one looked like it's decent.
Nikola Tesla is probably one of the most appreciated scientists in the field of electronics because of all the inventions and technological advances that we use to this day. The two topics most influenced by him are the use of alternating current and wireless power transmission. And it is precisely the latter of which I want to talk to you in this episode, as specifically through one of his most recognized inventions. In this episode, we will see how a Tesla coil works. Before talking about how and why a Tesla coil is capable of generating those gigantic electric arcs, we have to understand what Nikola Tesla's objective and logic was when developing this device. In the previous episode, we talked about how an inductor or coil works, and I explained how an electric current flowing through a coil can generate a magnetic field, and also how the variation of a magnetic field can induce a current in another coil. Understanding these two physical phenomena, it is easy to assume that we could apply current to a coil to generate a magnetic field, and in turn use this magnetic field to induce a current in a nearby coil, with which we would be transmitting power wirelessly. The problem with this idea is that magnetic fields lose their strength quickly as we move away from the source, and therefore, when separating the two coils, the energy transmission becomes more and more inefficient. Now let's see how the Tesla coil overcomes this limitation, taking this concept to the extreme. The logic is the same: to make an alternating current go through a coil, but with extremely high voltage and a specific frequency to be able to transmit energy over greater distances. To achieve this goal, there are mainly two concepts that we must understand. The first is the voltage rise through a transformer, which in simple terms is made up of two coils. A primary winding, which is connected to a current source and generates a magnetic flux, and a secondary winding, which converts again that magnetic flux in a current. But
alright, I think I have something in there. So where does it go in this part? Anyways, I'm going to test it out soon. I'm just trying to figure out what in the world is happening. Because again, I don't have a electrical engineering background, so I'm going to have to do a deep dive on this. Okay, but anyways, so there's a coil underneath there. I'll make this bigger after. Okay, there is some coil in there, but it's like, what? Okay, that's a tiny one underneath, and there's a giant capacitor, and let's see what happens here. Okay, so basically you got a primary coil and then a secondary one. Basically, you spin electricity goes into this one, creates a magnetic field, and then this one induces magnetic field. That magnetic field goes to this one, which induces a current.
But the interesting thing is that if the number of turns on the secondary winding is greater than the number of turns in the primary winding, an output voltage larger than the input is generated.
Okay, so there's the key. Okay, so the primary one is, you got these thick copper ones, these thick coils, but this one has more windings and are much smaller, so the voltage is going to be much higher. So in other words, the pressure is much higher here. Think of it as water. These are basically thicker tubes right here, and then you're you're spinning the ether and then causing the flow to go through a tiny one here. So the pressure's higher, but it's going to be less amperage, I would assume. Yeah, so less amps, higher voltage.
A simple way to visualize this behavior could be to imagine that we have a few batteries in series. Every time we add a new stack, the voltage adds up. Now, if we make an analogy, with each turn of the secondary coil we will realize that each one of them acts as a voltage source, just like batteries, and therefore every time we add a new loop it will add that voltage to the total. And although in the next video we will talk in more depth about how a transformer works, I still haven't mentioned one of its characteristics which is extremely important to the operation of Tesla coils: magnetic coupling. This characteristic refers to the efficiency with which the primary coil affects the secondary coil. That is, if an alternating current wave enters by the primary coil, the wave that will come out of the secondary coil will have the same shape, but with a different voltage. In most cases, the idea is that the coupling is as high as possible, but not on Tesla coils, precisely because of the second concept that governs their behavior: using a resonant circuit. A resonant circuit is made up of an inductor and capacitor, which, as we have seen in previous episodes, are components capable of storing energy, although they do it in a different way, the capacitor with an electric field, and the inductor with a magnetic field. The effect of connecting these two components in a closed circuit is that, in theory, we could keep an electric current flowing cyclically indefinitely. Let's suppose that initially the capacitor is charged. Being in a closed circuit, it will start to discharge, and by doing this a current will go through the inductor, which will start to form a magnetic field. But when all the charges of the capacitor have been used, this magnetic field will begin to lose its strength, inducing a current in the opposite direction and recharging the capacitor until the inductor loses all its magnetic field, starting the cycle again. Clearly, in the real world this is not going to happen indefinitely because the circuit itself has a resistance which will gradually slow down the electron movement. But this does not mean that we cannot benefit from this behavior. A resonant circuit has two great benefits. The first one is that even when they can't hold energy indefinitely, they can do it for a certain period of time, although losing strength in each cycle, something similar to what would happen in a pendulum, which just by pushing it once, is able to keep oscillating at a regular frequency. And also, like a pendulum, if we push it periodically at the exact moment, we can amplify the end result, even though we are only applying the same amount of force that we had initially used. The second benefit of resonant circuits is linked to the fact that they have their own frequency at which they oscillate, which is defined only by characteristics of its components. That is to say, the inductance of the inductor and the capacitance of the capacitor. Taking this into account, the inductor of the circuit will generate an electromagnetic field whose oscillation is going to be equal to said frequency, which, let's remember, is constant. And did you know that another object does something similar? A tuning fork, which when hit, generates a specific frequency. And I mention it because you surely have heard of the following experiment, in which, when putting two tuning forks with the same frequency of vibration and hitting just one of them, eventually the second tuning fork will start to vibrate because the pressure changes traveling through the air from the first tuning fork will move the second one just at the exact moment so that their movement is amplified. Exactly as in the case of the pendulum. So thanks to this behavior, if we position two resonant circuits, but only the first one is active, eventually electromagnetic waves generated by its inductor will begin to induce and amplify a current in the inductor of the second resonant circuit, enabling power transmission wirelessly over much greater distances. Having taken all
so basically ether vibration and resonance, and it's transforming, transmitting energy. It's epic stuff. I just want to check if any comments on the threadcast. None yet. All right, let's go. Okay, let's continue back on this. This is a very, very interesting video. Yeah, so then basically you have the magnetic field, which I think is just electrons spinning in a circle. And this one is electric field is just electrons piled up, not spinning. So this goes, they discharge in here, it spins up, and then once it's fully spun, it's kind of, then it has to like kind of unwind itself or something like that, and then brings it back. But anyways, I'm just thinking through, and then we'll test out the Tesla coil soon.
This out of the way, now we are able to go back to our Tesla coil to see how it works. Nowadays, there are several ways to get the same or better results, but we are going to focus on one of the original models because of their simplicity. The first thing we will need is an alternating current source, which will be connected to a common transformer. That is to say, with a high magnetic coupling between the two coils. With this, we will obtain an alternating current with higher voltage, but whose frequency is equal to that of the initial source, say 50 or 60 Hz. This new alternating current is brought to a resonant circuit with its corresponding capacitor and inductor, which is usually called the primary coil, also including...
Oh, so that's the primary coil. So the whole thing together is called the primary coil. Let's see that again. So basically
60 Hz. This new alternating current is brought to a resonant circuit with its corresponding capacitor and inductor, which...
Okay, yeah, so yeah, there it is. I think I grasp it now. So there's the inductor. There is something here. It's like a coil, and then there is a giant capacitor over here. There's a capacitor there. There is a coil there. Anyways, we'll see what I'll show you the thing I have. Okay, let's see the components inside up close. See if it shows up close. Okay, it's hard to see. Let's see. Okay, so there is a capacitor right there. And then would this be the inductor or the primary coil? Yeah, I think that's probably the... Okay, so where does the power go? Power goes into here. Anyways, I'm trying to decipher this. Okay, Timothy Someone's in the house. Let's go. All right, epic stuff. Okay, yeah, so I'm trying to figure out how the Tesla coil works, and then I'm going to test it out soon. And also see if there's any safety concerns. This is a pretty powerful one. Okay, so there's that stuff. Let's see, what else was that? Is there another side to it? Okay, let's see. Let's go zoom in. Okay, so yeah, I have this thingy here. Okay, that one. So this is the capacitor, I know, because it's just a giant battery-like thingy. This one, would that be the secondary? Or that'd be the. So the bottom part is the primary. I think that's what they call primary coil. So you have an inductor. I'm assuming that one. But there's another thingy that's similar to it. But anyways, trying to figure this out. So you have. It goes in primary AC like that, couples with this same frequency, higher voltage, thinner wires. And just more loops. Goes to a capacitor, and then there's the capacitor, and this thing right here. That's the discharge thingy. What is that for?
With its corresponding capacitor, alternating current is brought to a resonant circuit with its corresponding capacitor and inductor, which is usually called the primary coil, also including an extra component which serves as a switch, which basically...
Actually, well, where's the inductor? So, oh, this is the inductor there. Okay, yeah, so this one is the inductor, spins, and I think that's going to be the initial circle there. There's the capacitor. This is the primary coil, secondary, the magnetic coupling, and then that's the getting that frequency high voltage. This is the capacitor. It loads up, and then it discharges into this part right here. That's the coil, and then that discharges back into this, and basically resonates back and forth into that.
A resonant circuit with its corresponding capacitor and inductor, which is usually called the primary coil, also including an extra component which serves.
Yeah, so basically, yeah, so the inductor would be the top part. So there's I think there's gonna be a coil on the top. Anyways, I'm trying to figure this all out.
As a switch, which basically consists of two pieces.
Let's go back here. What is this one?
Also including an extra component which serves as a switch, which basically consists of two pieces of metal that are extremely close, but not touching. The function of this section of the Tesla coil is that the primary coil emits an electromagnetic field with the frequency of the resonant circuit. When the transformer induces a current, charges begin to accumulate in the capacitor without having any other possible way. But as the source voltage grows with each oscillation, the electrons try to find another path. And the second best option is where the metal pieces are, jumping through them with a spark. This way, the spark will allow the passage of the charges that were accumulating in the capacitor, quickly discharging it. But as soon as they do, the spark will also disappear, because the capacitor will be again the best path for the current, repeating the cycle again. This time the cycle will not be at the same frequency that the initial transformer was giving us, but rather the frequency at which sparks occur and the capacitor charge and discharge. That is, the intrinsic frequency of the resonant circuit. But now let's forget about the capacitor, and let's focus on the primary coil.
Yeah, that one I'm not exactly sure how they did that. But anyways, what I'm gonna do is I'm gonna do a summary of this video. Then I'll ask Grok AI eventually, like, what in the world's going on here. Okay, I'm gonna close this stuff here. Go back to this one and summarize. So this will just quickly summarize that. Okay, I'm gonna go back to this part here, and then I just need to. Yeah, I don't understand what you meant by this one. I'm assuming the excess goes there just so it doesn't blow up the capacitor. I'm assuming that's the reason for it.
But as soon as they. This way, the spark will allow the passage of the charges that were accumulating in the capacitor, quickly discharging it. But as soon as they do, the spark will also disappear, because the capacitor will be again the best path for the current, repeating the cycle again. This time the cycle will not be at the same frequency that the initial transformer was giving us, but rather the frequency at which sparks occur and the capacitor charge and discharge. That is, the intrinsic frequency of the resonant circuit. But now let's forget about the capacitor.
Yeah, so this frequency won't be the same as the one being inputted into it. But I want to check where I'm gonna ask Rocker. What is the purpose of a discharge of a spark discharge gap in a resonant primary coil capacitor setup for a Tesla coil? Is it so that excess charge in the capacitor doesn't blow it up? I'm just let's see what Grok AI says on this capacitor. Just correctly spelling it. Okay, let's see what these guys say. So Grok AI is pretty deep right here. I think it's to induce oscillation. Okay, interesting. That's okay. Because the thing is, because he gave the theory behind it. It says it induces oscillation without. It just didn't even include that in the theory. So it was able to induce it already. So the spark discharge back in a resonant coil, in a resonant primary coil capacitor setup for a Tesla coil serves a critical role in the operation of traditional spark gap Tesla coils, SGTCs. While it's related to managing energy, its primary purpose isn't to just prevent a capacitor from blowing up due to excess charge, though it does help protect components. Let's break it down. In a spark gap Tesla coil, the primary circuit consists of a high voltage capacitor, primary inductor, primary coil, inductor, and a spark gap, all forming a resonant LC circuit. The spark gap acts as a switch that controls when energy is released from the capacitor. Oh, okay, that's what it is. Yeah, so basically it's a switch. There it is. He said it already. So it's a switch as it loads up, and then it goes through, then it gets discharged, and then once it goes down, all the current goes back into the capacitor, as opposed to the spark gap, because there's a gap between. When the capacitor charges to a high enough voltage from the power supply, typically a high voltage transformer, there in a spark gap ionizes, breaks down, creating a conductive path of spark. This closes the circuit. All the energy stored, all the energy in the capacitor to discharge rapidly to the primary coil. Then oscillation initiation. Once the spark gap fires, the capacitor discharges, and the energy oscillates between the capacitor and the primary coil at the circuit's resonant frequency. This oscillation generates a rapidly alternating current in the primary, which induces a high voltage, high frequency current in the secondary coil via electromagnetic coupling. And that's why there's a super tiny thin wire in the big secondary. Spark gaps firing initiates this resonant oscillation, which is the heart of Tesla coils. Anyways, timing. It basically pulse energy transfer in and out. Okay, so it makes sense now. The question is, that's traditional. Does mine include? Does my Tesla coil include a spark gap? I don't think so. Yeah. Does my Tesla coil? Let's see what it says. Okay, these are high specs, 250 watt average, input 110 to 220 AC. Arc length up to 20 centimeters or more, adjustable, music effects, square wave, no ground wire needed. Okay, SG traditionally uses spark gap as a mechanism to switch the discharge capacitor into the primary, creating a loud pulsing noise and requiring high voltage transformer. Your Tesla coil almost certainly does not include a spark gap. It appears to be a solid state Tesla coil SSTC, where the switching and resonance are handled electronically rather than mechanically via spark gap. The music feature direct mains, power, and adjustable arc length, all aligned with SSTC technology. Check the unit for physical spark gap, 2 metal electrodes separated by a small air. Manual, review the user manual. The thing is, I got no user manual, so there's literally no user manual in here. There was no user manual given. Can you check their product listing for it? Or suggest one from a similar coil. Yeah, there's basically nothing there. Okay, so anyways, so that makes sense. Okay, so there was no user manual. Okay, let's continue on this journey. And this one does not. Yeah, so I don't see anything in here. There is no electrode touching each other, so it does it all electronically. Switches on and off. Okay, anyways. And where's that coil? Is that just that big one there? Okay, so that's just wires. I think that's a main wire one. Okay. I think I grasp it. Okay, let's continue on. Let's see what the grok says. eBay listing how to use. Please refer to user manual for detailed instructions. Okay, user manual. There's no mention user manual. Where is it getting it from? It's probably an archive of it. There's no mention of user manual. Like, where is this guy getting it from? Oh, view all revisions. Okay, so there is no user manual. No, there's something else. Manual. It's like, where's Grok looking at this? Assumes the manual is included and doesn't provide online. Okay, contact the seller. Okay. Don't touch arcs or the terminal while on. High voltage can shock. Turn on the switch. Unplug. Let it sit for a minute to discharge residual. Oh, that's to shut off. Okay, this is product page. Plug in mains. Switch on the arcs. Connect via 3.5 music mode. Avoid prolonged contact with arc. No grounding needed. Okay, anyways, let's continue on this Tesla coil stuff. No link to PDF. There's nothing there. Yeah, there's nothing. But anyways, it told me to buy it, and we'll figure this out.
Capacitor, and let's focus on the primary coil. Again, it will be passing an extremely high voltage, which will be oscillating at the frequency of the resonant circuit, and therefore it will generate an electromagnetic field oscillating at this same frequency, which we can take advantage of with the secondary coil. Again, we will have two coils nearby, and with a big difference between the number of turns of each, which means that we will have a second transformer in our Tesla coil. This will increase the voltage in the secondary coil, which, by the way, if we analyze independently, is connected to ground, and in its upper part it has a metallic piece of toroidal shape. It has this shape mainly to be able to accumulate a greater charge and prevent it from ending up escaping into the environment by the corona effect, and therefore also preventing the voltage of the assembly from increasing further. If you remember the episode on spiders that fly using electricity, I mentioned that the corona
Wait,
effect...
what? Spiders flying with electricity? What in the world's going on here? Where are we right now? Let's see this spider right here.
If you remember the episode on spiders that fly using electricity, I mentioned that the corona effect generally occurs when there is a large potential difference between an element and the environment around it, which is accentuated in high and pointed places like the masts of a ship. Well, the top of a Tesla coil is just the opposite, or at least attempts to be, because by preventing charges from moving into the environment they begin to accumulate. And finally there comes a...
So interesting, a donut shape, smooth around it, prevents charge from discharging. Interesting.
Point where, again, the potential difference will be enough to ionize the air around it. But this time with much more energy, because we had more accumulated charges and ready to jump, generating the electric shocks everyone knows and loves from Tesla coils. But that's not all about how a Tesla coil works. Do you remember the properties of resonant circuits that I mentioned at the beginning? Although it doesn't seem like it, the section with the secondary coil and toroid form a new resonant circuit in which there is not a physical capacitor but a capacitance. More specifically, a parasitic capacitance, a phenomenon that occurs whenever two conductors with different voltages are relatively close. And I say relatively because when we are talking about voltages as high as a Tesla coil, which can reach several hundred or thousands of kilovolts, this phenomenon may be noticeable among conductors who may be several centimeters away or even meters away. Now that we are clear that two resonant circuits exist, in theory we could take advantage of its ability to transmit energy more efficiently. But for this to happen, both circuits must have the same resonant frequency, and the resonant frequency of the section with the secondary coil cannot be precisely modified, because there is no capacitor to which we can measure its capacitance. For this reason, some method is usually included to vary the capacitance of the first resonant circuit, in such a way that both are the same frequency. With all this, we would only be missing one more feature to fully understand how it works. Did you think it was going to be something simpler? Me too, but we are talking about an invention of Nikola Tesla. No wonder it is often said that he was ahead of his time. So breathe, subscribe, give oxygen to your brain, and let's continue. The last detail of the operation of a Tesla coil is in the form of the primary coil, which is designed with the aim of reducing the magnetic coupling between both coils. In practical terms, this means that when a voltage oscillation goes through the primary coil, the secondary coil will generate a higher voltage for the difference in the number of laps between both coils. But it will also continue to oscillate, even if the primary coil stopped working. Do you remember the pendulum example? It's exactly the same. We could say that the secondary coil is the pendulum and the primary coil is the force that pushes at the exact moment. In this way it is possible to generate a much higher voltage than the one that had been started, and which is also oscillating at the resonant frequency. Now that we fully understand how a Tesla coil works, let's get back to its goal, transmitting power wirelessly. The electrical discharges in the air are striking, but in reality do not fulfill any function. We could even say that they are undesirable, so we will keep our Tesla coil at a lower voltage to avoid these losses, and to only generate the electromagnetic field. If we position a fluorescent lamp near the coil, it will turn on, because the electromagnetic field will give it enough energy so that the gas inside start emitting ultraviolet light, which is later transformed by a phosphor layer in visible light. In a similar way to what we saw in the episode on how a light-emitting diode works. But this way we will not take advantage of the potential of the Tesla coil at all, since we are not using its resonant circuit quality. In fact, the distance at which the lamp will light is quite short. The true way to use a Tesla coil to transmit power wirelessly is using another resonance circuit with the same frequency. In this way we can be much further and still generate an electric current as a result, just like the tuning fork we mentioned at the beginning. And now to close this video, the million-dollar question: why don't we use this technology to have wireless power everywhere? And the answer is that we do use it. Practically every day. Just think of a radio signal. On the one hand we will have a giant antenna emitting electromagnetic frequencies, and on the other hand the radio that in its interior has a resonance circuit that we can adjust to receive only the frequency that interests us. Now how to use those frequencies to transmit information is another story, maybe for a next episode. Remember to subscribe, share and support me in Patreon if you think what I do is worth it.
Alright, this was pretty epic, guys. Yeah, this is one of the better explanations going on. And let's check in here, see what this summary says. Okay, yeah, it's a pretty cool summary. Bought all this understanding Tesla Coil, Nikola's vision for wireless. Okay, so that's pretty epic. And yeah, the fact that you can resonate with at a distance, and also similar to the other one, talking about radio and so on. It brings me to this video. It's pretty fascinating and a bit scary. Let's play this video. This is Dancing Aphids. This is from I think like 2010 or something. Let's play here. Or yeah, so this was from James DeMayo. Yeah, this was one of the Orgon accumulator guys. One have Wilhelm Reich's yeah, promoters. Okay, wonder how Tesla learned all this stuff. But yeah, Tesla again. He's big name. I think he was a big insider as well, or being used as a just put his name on there. But again, because I think this technology has existed long before Tesla. Okay, let's play this. Dancing Aphids excerpt.
This picture shows some aphids on the leaf of an orange tree shortly after radar equipment was installed at a nearby airport a number of years ago. I noticed that every few seconds, all the aphids would tense up in unison and do sort of a little dance, as you see in the picture. Upon further investigation, I found that the interval of time between the activity of each dance coincided exactly with the rotation of the radar rotor device at the airport, which was a distance of approximately 14 miles.
Okay, yeah, so it's 14 miles away, and this guy's saying, yeah, this was how does cell phone smart meters and all that, and this is from 12 years ago. Holy, now we got the 5G COVID mumbo jumbo. Funny how Elon seems to be playing a similar role. Yeah, Elon is that, yeah, Elon is, well, he's not even doing much of the science, he's more of the businessman side, but using the Tesla name. Anyways, so this one, 14 miles away, these little dancing insects are getting, like, are vibrating because of the radar 14 miles away from the airport. So that's some food for thought. And some other stuff here I want to show quickly before I start doing the Tesla Coil stuff. Oh yeah, so I have some other electromagnetic stuff here. Some of them I was actually working on. This is let's go right here. Magnetic torque. Yeah, this one's a pretty cool video. And also this one right here. This is. Oh, well, let's open this. Whoops. Open this one here.
This is right.
This one's pretty fascinating. So if you have this magnet and put it at an angle where this is incoming right here, and it seems to have a bigger push than incoming. So this might be over unity stuff. So I want to actually test this out.
Raised magnetic torque generator 4. So that gives you some.
Okay, so basically it's at an angle. So this one's aiming towards this way, but then there's the disc is on this, so it's an angle relative to the edge of the disc. And then if you get closer to this,
I'm going pretty good.
and he has it connected to the generator. So basically, as this gets pushed, if this spins and then creates a little lights up the LEDs. Yeah.
So that gives.
So see this little push.
I'm going pretty good.
So all you do is move it to it, and it flies. It flies faster than the incoming.
So that gives you some
It pushes outwards, and if you go backwards, the pull isn't as strong as that.
push.
And he does some other mechanisms
That's
as well. And then there's this theory right here.
by magnetic expansion or release. That's very sudden, and that pushes it away.
Anyways, I'm showing that because I'm gonna do some experiments on this end because I think there's something to that. That's fascinating. So if you have it at an angle, another magnet coming in, it gets pushed out that way faster. So that's some over unity, very possible over unity stuff there. Okay, so that's that. And then this remote view, this is from Bob Greener. This mainstream paper argues that heavy elements are synthesized on Earth by LENR. And this is a mainstream paper, or semi-mainstream, I'm not sure exactly. But this is from Scientific Research and Academic Publisher. Let's see how many views this is. 2.4 million. Yeah, it's pretty mainstream. And this is from Israel right here. Israel scientists basically saying low energy nuclear synthesis in earthquake, volcanic eruptions, and genesis of heavy metals. And if you haven't seen my other videos on expanding Earth, so possibly, yeah, so Earth is expanding, getting heavier using cold fusion. So basically, cold fusion synthesizing heavy elements as opposed to the mainstream somehow hot fusion. If you would use my free software, you would learn how magnetic fields work in 3D. Ancient DIY tech. Okay, what's your software? Can you send it? Can you send it on my email? Okay, I'll check your channel right now. And again, I have my own thoughts on how magnetic mumbo jumbos work using the Ether model. Let's go. Ancient Tech DIY channel. Okay, let's check the videos right here. Subscribe. Okay, and where is your download my webcam stream accumulation software? No spam. Yeah, anyways, where is your model right here? The link is in my channel. This is free webcam stream accumulation software. I don't know what that means. Oh, image accumulation, what does this mean? What in the world is this thing? That was a tool to be used with almost any webcam for various purposes like tracking animal. Seeing the copper size of copper cables they run into those 5G is a serious amount of power. Well, but is this the link you're talking about? This one here? This is seeing, what are we seeing right here? Tracking animal movement by tracing it and so on. Okay, that's tracing stuff like that. Let's see what this is. Magnets and ions. Let's see this. Okay, periodic table of elements. And does this track the elements or what does this do? I'll go fast forward. What are we watching? There's a magnet inside a coil, and these stuff forming there. Elapsed time for. Okay. Anyways, yeah. Anyways, we'll have to wrap my head around this. That's pretty fascinating stuff here. Okay, so I'll save this thing. And also, what I'll do is I'll put your channel. So for those again, I'll put it in here. So if you're on my Telegram, just post stuff here. You could put links in here or on the Threadcast. So this one will be pretty good. It tracks ions and magnetic fields. Real epic stuff. Okay, interesting. So also, if you can post stuff here, go in my Telegram, post links there, and then it'll be easier to all in one place. So basically, in here, I'll put the link to your channel and that website. Okay, so you can track ions in there somehow. That's fascinating. Okay. Anyways, we have 1 hour and 3 minutes left, and we're gonna have to figure out how the Tesla Coil works. Okay, so we pretty much have the same general idea. Go back here. Request manual. Okay, today I'm gonna go contact seller right now. Okay, I'm gonna contact him right now. Okay, contact seller. Shipping, it arrived. How do I contact? Still have questions, contact seller. Okay, not just ions. Okay, interesting. What else does it show here? Contact. Send a copy to my email. Hi, do you have a user manual for it? Tesla Coil. It arrived, but there is none. Also, I didn't realize that power cord was the European size. Euro, and you send me a one for Vancouver, Canada. Outlets, or recommend a cord slash converter. Okay. For example, living water organisms, drones. Okay, but how does it do that? How does that thingy detect it? Anyways, okay, so guys, we are gonna do some stuff right now. I'm gonna make this bigger, see what happens. Okay, so Grok AI, contact the seller, and we're gonna make this webcam bigger. Okay, we're gonna make this bigger. I'll move this over like this. Okay, so you guys can see my webcam. See how I can pull this out. Here. How far does this go? Alright. I should get a tripod. So we have it right here. This Tesla Coil. Yeah, there's the Tesla Coil right here. We're gonna figure out what in the world is going on. And I have it at a good distance away from my electronics and stuff. Anyways, so I'll go figure out a tripod setup or a table. So I'll just put it like this. Okay. Alright, we are good to go. Okay, looks like a standard input for power. Go grab a cord from... Yeah, I have something else. This is the one they have. This one says it's like 250 volts, 10 amps. I have another one. I have it connected here. I didn't plug it in until... So this was my computer one. This one, I think, is like 100 volts, 110 or something. Anyways, we'll test this out. Okay. Alright, so we got this set up. I'm gonna move this somewhat close. It should be fine. Okay, so it's plugged in, the lights are on, and now the question is, how in the world do we use these? Okay, so we got the sound thingy, and then we got this charger thing. And how does this charge? Oh, does this need to work or something? Okay, I think I'm gonna move this to 110 volts. Okay, so there's a setting there. Okay, we're doing live experiments. Let's figure out. Okay, 2 meters are okay. Well, this one is half the strength. Fire extinguisher handy. No, we're just doing a test run right now and see what happens. Okay, this thingy. I would assume it keeps it away from it. Okay. So that's the coil. So it's probably working without anything else then. So this electronic needs to be at a distance away from it. Okay, that makes sense. So this one needs to be distance away. Yeah, so I can move this away here. Okay, so I think I have a general idea. Oh. Okay. So how long does it take to power up and stuff? Okay. 2 meters are okay. Have this. Okay, so now... would that work just by itself then? Do I have to do anything? Okay. I'm gonna ask Grok right now. Okay, let's go back here. Okay, we're back on here. I'm gonna actually increase this table where I'll be standing. Okay, Mav's in the house. Let's go. 2 meters are okay. Okay, fire extinguisher. We don't have any, but we will figure stuff out. And we will do stuff. Okay. Okay, let's make this a bit bigger. And make my face. Oh, I didn't even. Oh, sorry about that. I didn't even press the other button. Okay, sorry about that, guys. I'll show that again. I had it. I forgot to make it. Okay, so this is a bigger one. You can see I have it plugged into a normal outlet, a normal plug thingy. Sorry, guys. Let me know if my screen, because I have to press 2 buttons to just switch. over. Okay, so I have that. So I have to press 2 buttons, which I absolutely hate. They used to not be able to do this, and now it's automatic. I can't figure that out. Okay, so anyways, make it like that. I have to press 2 buttons, which is the worst of all time. So basically, to illustrate what I mean, so if I have issues when not showing the full screen, so this is my recording software, or this is the live stream software. So if for example, I did this, just to illustrate my frustration with this thingy. So I made it like this, and then I thought it was showing this, but I need to press this button to do that, which is absolutely brutal. All right, let's see. Okay, there's John Hutchison in the house, guys. Let's go. John Hutchison is in the house. I'm gonna go like this. Hey guys, John Hutchison. We're testing out the Tesla Coil right now. Okay. Hutchison effect. They are fun. John Hutchison says, Matthew, and mine at my parents' house, 2 feet in diameter, 8 feet high, plumb wound, 8-gauge wire, and a spiral primary of 4-inch wide copper flashing. Used a 3 kV 21,000 volt transformer. Epic stuff. Cannot write all here. Wow. Amazing, John. Okay, so here what he just said. He said at his house he had a 2 foot in diameter. So 2 foot in diameter. Where's my thingy? So yeah, 2 foot in diameter. This is brutal. My head's giant. Okay, yeah, okay. So make it like that. Yeah, so we had 2 foot in diameter. It's like this, it can't even put in my hands. And then 8 feet tall. 8 feet high, plumb wound, 8-gauge wire. Okay, it's absolutely wild. And to show you this, used my own cap oil and glass capacitors. Holy. Okay, so John is on another level. Did yours have a spark gap too, or it's Solstead? Okay, 3035 North Vancouver. Okay, epic stuff. Let's go to maps. This is John's parents' house. It's right here, Crescent View. Okay, so this is all the way there, and I live just down here. So basically, I can't believe John lives right next to me, pretty close. I'm over here. So basically, I'm pretty much like an hour drive away from him. Okay, so that's fascinating. So right there, that's where John had a 8 foot high, and I remember this because you have this one Hutchison effect. Invite John over to play. Yeah. I do want John to come over, or I should go over to his. He has a bunch of these. Great coil. I then built disruptive transformer. Wow, epic stuff. Yeah. So it reminds me of this video that I uploaded. The one of the most views, 51,000 views right here. Holy. Okay. Okay. And there's a coil right here. Oh, yeah. So you talk about the ginormous coil. Yeah. This was at the beginning right here. Coil. Let's go to the coil. Yeah, so these are some ginormous Tesla coils.
And other effects are duplicated in Hutchison's basement lab. But it was his love of old equipment that led to advanced experimentation.
This is an old dynamotor, turn of the century. And,
So I want to get to the,
actually, a small one.
Find it from Tesla's friend Thomas Lee Richardson, who wrote a book in Teslas. Okay, this one right here. Is this the one you're talking about? This one is monstrous Tesla coil right here. And he says it took him 1 week to wind. This might be it. See this? Look at how ginormous this Tesla coil is.
It combines recycled electronics in huge hand-built coils that together defy some established laws of physics.
That's a Tesla coil. In regards to Tesla, it would be probably a very small one.
This is a small Tesla coil, according to Tesla. This is absolutely massive.
Can put out about 1.5 million volts.
Did you build it?
Yeah.
How long did it take you to wind something like that?
It took me about a week to do the whole coil. The winding itself, I guess, about a day and a half.
So a day and a half of winding, a full week to do the whole Tesla coil. And John says lots of unpublished stuff Thomas had. Okay, yeah, that's epic stuff. I need to get hold of those stuff there. All right. Anyways, so I have the Tesla coil charged up. I'm gonna ask Grok AI, what in the world are we doing? Okay, so Grok, I plugged in. Let's see. I'm gonna go volts. Where did it go? Let's go at the bottom. Okay. Let's say outlet. Okay. I plug into this. Okay, so avoid extension cords impossible. Okay, so anyways, initial power on. Locate the power switch. There's no power switch. It just turns on. I don't even know if there's a power switch. Okay, I plugged in the 120 volt AC cord, and the LED light went on. Okay, give me instructions on what to do next. Is it on? And keep in mind safety concerns. Okay. Yeah, John was having a great hair day in that clip. Yeah, and I think John was wearing. Yeah, so I thought it was too, but John, I think you're wearing a wig as well. So this is, I think, John, was this hair real or is it a wig? John did like dressing up. Yeah, his hair is absolutely wild. Was this all natural? Actually, even the reporter's hair is nice. Holy, everybody's got flowing locks. What's going on here? So John, yeah, the $1 million question is that the hair real? In Hiroshima, 2 massive coals. My sponsor Matthew has the videos. Oh wow. Yeah, so I'm gonna go through all of your videos still. I'm currently like working. I'm spending a lot of time working on the Inventor 3 experiment, which I firmly believe he's definitely onto something. If you haven't seen Inventor 3, guys, I'll open up. I'll open up right now. Yeah. So anyways, yeah. So John, $1 million question: is this hair real? And also, I'll go back to this. Here, I go to the all notes, full timestamps right here. And yeah, so John, he had a, it's not here, it's an antenna. Okay, so John, is it an antenna? So, and there's a full transformation. I think this one, okay, this one I think was real hair, or which one is real hair, John? This one looks like it's real. Yeah, this one looks like a wig, it's curly. Someday we'll upload it. Yeah, I definitely will upload that. Yeah, this was when you were in the Beatles. Yeah, so man in hair like a Greek god. Yes, yeah, so John, let's go. And the carrot experiment is pretty epic. If you have that carrot somehow frozen, okay, I'm working. I'm spending a lot of time working on dyeing. Interesting. Okay, anyways, also there's another person that kept messaging me, John. This guy, he wants to ask you a question. Okay, this guy's name's King God. Hey, I'm so sorry for bothering you. This is dumb, but can you make a video on time travel and if it's possible or not? Wormholes, or ask John Hudson. I don't know. I'm sorry for bothering you. So I said John is joining live stream on April 5th, so you can ask him then. Make sure to be in the chat. Okay, sorry, but do you think John can help me out? Because I really want time travel. Okay, so John, what should I say to this person? He wants to time travel and wormholes. And the questions, yeah, is that possible? And I think you've talked about time dilation and so on, but I think he wants time travel. So let me know what you think is possible, and I'll let him know. Okay. Okay, so let's continue. Okay, so now that's that. I have some. I want to show something else quickly. Yeah, so this is the one I'm working on. It's gonna be an absolutely epic video. That's what we're all. Yes, we are traveling forward in time. So in my view, I think time is just like a social construct. Okay, ancient tech DIYs as it's possible, yes. Yeah, well, I think, well, reality is an illusion, and so on. So anyways, so I'm going to open up this quickly. It's opening up, and then we'll get back to Tesla Coil. We have 47 minutes. We got to get to power through and figure out how this Tesla Coil works. But I do want to show this, because and then I'll get back to uploading Hutchinson effect stuff. But this one is just, I think Inventor 3 is onto something absolutely massive here, and he might do this experiment during the stream next week. And also, John, can you make the stream next week? Next week, April 5th, guys. John Hudson, if he's still feeling well, and also, how are you doing, John? How are you feeling right now? All right, guys. So here at MES, we have John Hudson on the show, and he's a good friend of the channel. And I saw your EVO post. Anyways, I'm loading this up. This one's in. It's taking a long time because I'm trying to make it as clear as possible, and I'm making like a full table of all this. And so for those who don't know, so this one here, he has a 6-foot copper tube, and then he drops a bunch of stuff inside and see how long it takes inside. And then he did the Boyd Bushman 2 magnets opposing each other. So anyways, this one here, here is a magnet that he drops in right here. This one is south side up, and drops it in.
Get over there. I hope to God you can see this or it's turning out. I have a feeling my camera is not focused on it. If I stick it right inside there.
Alright. Yeah, so 21 seconds it takes to drop a magnet right here down a 6-foot copper tube. And then what he did later, and I made a table of this, so basically I'm going to make it all scientific and so on. Then he puts a north side. The south side kind of leans a bit, which is interesting. Anyways, and then he puts this ball in. Ball goes in 9 seconds. And then I'm basically getting everything. But now he puts these, he super glues these together. South side up, north, north. Yes, north, south side on the ends, and the north are glued together. So it's opposing magnets. And then he drops it down. But he also adds 2 more tubes. Initially, I thought it was 11-foot tube. No, it's actually same 6-foot tube. And then he puts 2 more tubes, copper tubes, around it near the center that are 5 foot long. Oh, this one I forgot to put the thingy there.
More copper.
Okay, this one needs to go down. Okay, this one needs to go up. Okay, I need to fix this up. I'm gonna save this. And this one needs to go to the bottom. This needs to be bottom like that. And this and this. I'm doing real-time editing. This one. Oh, whoops. And just copy this down. And yeah, so this one. Yeah, this will go like this. This is 5 foot. So basically, the 2 copper tubes are 5. The exterior ones are 5 foot. And this one is the center one is a long 6-foot one. But anyways, what? Oh, hi Matthew. Okay, John, let's go. So basically, what happens is he gives more. Basically, gives more more copper there, so it can hold the magnet even longer. So anyways, and then I did the measurements and everything on here, and so on, and so basically, and he has the numbers, and I'll show you that soon. So he drops this in. Okay, he drops it right here. North, Super Bowl, yeah, loves Matthew shows. Let's go, John. Yeah, thanks. This one I'm working on the Inventor 3 one. I think I think it's definitely something onto something absolutely monstrous right here. So this is north, north glued together. Watch it.
Drop.
And look how long it takes for this one.
Come on, focus, focus, focus.
It's literally floating.
That's beautiful. That's beautiful. It's hard for me to keep my camera perfectly centered here. I'm trying my best. Come on, every time I get over it, it's, what the heck is going on?
So it's going down 6 feet, and it's taking absolutely forever.
Okay, it's still falling. Let me show you. Okay, still falling way down there. Whoa. Okay, you could have to watch on the videotape how long this is actually taking here. And it should be,
there it is.
Just follow.
Yeah, 51 seconds, north, north. 51 seconds, and it's double the weight. Okay, keep that in mind, double the weight.
Just heard it. I hope you heard it.
Okay, so basically, and I have, this is what he listed before, 40 seconds, but I don't think he timed it. So this one, but anyways, I'll fix these up. So basically, the triple tube right there, he gets it in 51 seconds. But then later, he does a 1 hour and 4 seconds. I mean, 1 minute and 4 seconds. But it's double the weight. And then I will go, yeah, so we'll go over here, drops it again, it's same thing. Alright, anyways, and then later he does this one in 38 seconds. I was able to record it. So one of these goes 38 seconds. He gets it 51, and then another one an hour. 1 minute and 4 seconds. But they're double the weight. But then if he puts the normal side, north and south together, they go about 30. I think 28 seconds. So literally over double the levitation. You can do the square magnets in a heavy support or aluminum or heavy copper aluminum. Yeah, for sure. But he glues them on. I think he did 100 experiments, but he hasn't filmed them. And that's one but he might do these live experiments on in this one here. Yeah, here is, I need to make this bigger. Okay, this one is the so I'm still working on this. It takes a lot of work to make this all scientific and like digestible. And it's a bit hard to see right here. But yeah, 28 seconds right there.
Okay.
So 28 seconds, the magnet's opposing, so it goes 28.1 seconds, another one 50 seconds. But then somehow he gets in an hour, 1 minute, 4 seconds. Anyways, so it's fascinating stuff. I'm going to close this and save and go back to the Hutchinson effect. Dr. Bass Awkward says, I think time is a loop. All time has already happened. We just got born over and over again along many different points in the loop. We have free will within a parameter, but certain events repeat indefinitely. Interesting. All right, let's go. Okay, so I'm going to close this. Okay, guys, this is a pretty interesting viewer there. And there's another part here. Again, I just want to show John this one as well. This one might have an over unity torque right here that this guy discovered. And I'll do an experiments video on this. I'll do similar to what I'm doing with Inventor 3's videos.
Here we got a good flash coming through there. So we're coming into the gate, not very much. And we get a good pulse.
So basically, if you put a magnet at an angle, another magnet, it can have a really big push. And this is with the generator too. So he does it without a generator at the end, and how much force it is. Okay.
So that's what led me to think that this is probably what's happening between the pull in.
I want to get to the 1.5 generator.
Pull through. And you had 3 or 4 of them stacked, you might be able to get something that was possibly self-running.
Yeah, anyways, but basically showing that if you put in an angle and it goes in, it just somehow flies past. So that's, and I think that's some torque over unity going on there. Anyway, so that's fascinating. Okay, I'm going to close some stuff here. And also, John, if you haven't seen Bob Ginner's latest post on Substack, mainstream scientists did a paper saying that earthquake, volcanic eruptions, and are possibly doing cold fusion or low energy nuclear reactions to form heavy metals. So again, we're in another planet right now. This is fascinating. And this also suggests that the gravity was less before and Earth's expanding, as per my earlier video that I uploaded. Okay, anyways, let's continue further on this journey. Okay, so I sent a message. The guy hasn't responded, and let's go back here. Deluxe power coil. Okay, that link doesn't work anymore. Okay. Okay, so right here I plugged in the 120 AC cord, and the LED light went on. Give me instructions on what to do next. Yeah, so we have 40 minutes, guys. Let's try to power through, see if it gets something here. Great to hear your Tesla Coil showing signs of life with the LED on after plugging. Here's what to do next, including safety based on current. LED lighting up typically indicates the coil's receiving power is in a standby or operational mode. It's likely on in some capacity. Keeping my eyes for gyro, Matthew. Okay, yeah, for sure. If you give me a gyro, if you have a gyro, I need a super powerful gyro. But also, we need to do that experiment. I need to message Alec. Alec messaged me about inspecting some other stuff, but he hasn't got back to me about doing the Eric Lightweight anti-gravity wheel. But anyways, we will. We need radioactive material too, John. Interesting. Yeah, I think it needs something like that. But I think Tesla Coil might be, to some degree, very helpful. I just gotta figure out exactly what it does, but I'm very confident I could replicate the Hutchinson effect eventually. And again, I'm gonna just do a tiny scale, put a penny, and then levitate a penny, turn it to dust, and so on. Okay, so LED lighting up typically indicates cold. Okay, anyways, it's likely on some capacity, but whether it's fully active, producing arcs depends on additional controls like a power switch or intensity adjustment. Confirm it's fully on. Locate controls. Look for a power switch knob or on the coil at the base or near the LED. The LED suggests power is reaching the electronics, but a separate switch might activate high voltage output. Turn on if needed. If you see a power on/off, if it's already on, there's no switch. Check for arcs. Look at the top arcs. If you see or hear small sparks, okay, I see nothing. Intensity knob. Okay. Let's say I haven't plugged. Teach Matthew to build a vacuum tube Tesla Coil pair F18. Okay, yeah, that's interesting. Yeah, so yeah, you had the vacuum tube set up there. That's fascinating. This one is like solid state and so on. So basically, I'll be dealing with what I can come up with this one and also learn how it is because I'm a noob. Radium chloride, interesting. Okay, so that's the material he used. But I think I can grasp this. But we will with your input, especially. Let's see this. I haven't plugged in. The other part which connects, which is the audio control. Okay, yeah, so I haven't connected that. Okay, so there should be no knob. There's no physical. The coil might regulate on power or audio. Okay. There are no sparks yet, and I haven't. Okay. Let's see. No arcs. Okay, so I'm gonna unplug this. So now we're gonna do some common years ago. Yeah, for sure. Might have to make it. So if I have to make it, we'll have to make it, 3D print it, and so on. Okay. I'm gonna put this here. I'm gonna do this right here. Whoops. Okay, and then make this bigger. And okay, so we are good to go. Right here. They have a sharp thingy here. Where's the sharp thing? Okay, so I put this. Oh, it's right here. Let's see what this does. Okay. Okay, nothing. It's doing nothing. There should be a switch or something on here. Okay, so there's no buttons I can press. The entire thing is off. Okay. Okay, let's say. Okay, I'll go back here, edit. Okay, and I'll go Control Z. Okay, and next. There are no buttons on the Tesla Coil box or switches, only on the audio control component. What is gyro you're discussing? I think he's trying to get a like old gyro or a gyro wheel. So yes, exactly. Yeah, John, which one do you mean? Ben, years ago, I got some R390s with the gauges. Because I do want to test out a gyro. I want to test out the... Yeah, he wants to find a good gyroscope. If you can give me a super heavy one, I want to test out this anti-gravity wheel one. And then also make one as well. Anti-gravity. So basically, I want to test this out. So my goal is to test this out in like a middle of like an empty soccer field. So the goal is to test out this one. Spin up this giant anti-gravity wheel and then just lift it up. But I want to get like 100 pounds or more.
That
and
speed.
do it like lifting up with a finger.
Question how you.
Okay, so this one he lifts it up. Like it's nothing. All right. So anyways, but I also think he's finding a super like one of those aircraft gyros. That'd be also useful as well. Because I do want to test also curvature of Earth. Getting one of those super fine ones and then just hold it and keep it steady in my room, and then see if it moves with the curvature of Earth. No, I mean with the rotation of the Earth. All right, guys, we are back here. I was asking Grok AI. Thanks for update. Since you're okay, I'm gonna go back here on. Okay, whoops. I'm gonna do this. Okay, so thanks for update. Since your high power isn't producing sparks yet, and you mentioned unplugged, and you mentioned an unplugged audio control component with switches, while the Tesla has none. It sounds like the coil's operations depend on this. Okay, so it depends on this one. Okay, so, and I need to keep it at a distance. Has no sparks and no switches. It likely houses the coil itself and power circuitry. LED is on. And power circuitry with LED. Interface turning coil fully on and arcs. Okay, so we're gonna turn this one on. All right. Okay, so we're gonna plug this thingy in. How do you like do stuff? It's impossible. Like just plug it in. Why is everything so hard? Okay, I can't even turn this in. Alright, we're more troubleshooting these. Unplug this. I'm gonna sit down. Alright guys. Hold a broomstick close to it, interesting. Okay, So we are doing some troubleshooting. Just connect, my goodness. Can't even plug it in. Okay, this maybe goes, oh, actually no, I was doing it wrong. Okay, that's the right way. And then this one, what does this do? Okay, then you rotate it. Okay, I got it. That's interesting. Okay, so we got this connected. And this one is separate power supply. Okay. Connect this thing in the middle. Okay, so we got this connected. Is that on now? Okay, I hear a noise. Okay, it's doing something. Okay. Oh, whoops, I forgot to do this part right here. Whoops, I hate this thingy, okay. Okay. Alright guys, I hear a noise now. I do hear a noise, I don't want to touch it. Okay, I don't want to get close to it. But, so this thingy is turned on. Okay, so this is turned on. These don't have LED light. I think it's a charger. Or connecting the computer to it, put your own audio. Okay, so I hear stuff going on. So now I have to increase the frequencies then? Yeah, so these dials have no idea what they do. I'll send a photo to Grok. Alright. Okay, if anybody knows what's in the world's going on, and I don't want to get too close to it, it's doing something. Okay, I'm gonna do a Grok AI. I'll go right here. Okay, I'm gonna go to Grok AI now. Alright guys, turn the power all up and the frequency, interesting. Okay, cool, okay, yeah. So I hear this noise. Oh wow, I can hear it, wait, this is wild. I hear in my audio, my phone, I hear in my headphones the same sound I get close to this thing. Holy, okay, I hear some weird audio. I think it's messing up with my thing here. Okay, so I can definitely hear it. It wasn't like this before. Okay, now, what? Okay, I can definitely hear the Tesla Coil with my earphones. Okay, this is absolutely ridiculous. Okay, we should hear a snapping noise. Can you guys hear anything? Or what, is that just me? I hear a little noise like zzz in my ear. And it's literally because of Tesla Coil. It's not because of me. Or my mic. Okay, so that's a bit scary. I'm gonna go to Grok history. Okay, I'm gonna upload this right here. Holy, I can hear my ear. Can you guys hear that? We should hear a snapping noise. I don't hear a snapping noise, but I hear a buzzing in my ear. I'm gonna turn this off. See what happens. Yeah, I'm gonna turn this off. Okay, and it's gone. Holy, I can hear the Tesla Coil with my headphones. This is absolutely wild. Can you guys hear it? Watch, listen to this. Okay, I can hear it. Okay, it's just me then. I'm gonna see if I can turn. Oh no, it's yeah. I can definitely hear it. Holy. Okay, so I can hear the Tesla Coil working. Okay, no. Yeah, this is I could hear it when the audio is so the audio is picking up the Tesla Coil. Stopping the low frequency. Okay, so we're literally gonna do some epic stuff here. Okay. I'll upload this right here. Okay. Oh my goodness. Okay. Anyways, we have 26 minutes, and then figure out later. So I can definitely hear it. So if I can hear it, imagine I hear. Okay, you adjusted. Okay, you can hear it. Okay. Is it safe though? Okay, I'm gonna just ask Grok. Okay. Here it is connected to the coil. I can also hear it with my headphones on my computer. It is a buzzing sound. Is this dangerous? Holy, okay, we got some buzzing, we got some 5G. This noise occurs incessantly in our homes because of the vibrations. We have grown accustomed to it. Many time mental issues are tied to this. Alright, so we got this AI, but this is cool, I can hear it. That's cool. Okay, so I uploaded this. Okay, so it should be refreshed right here. It should show it now. Whoops. Yeah, I'll put it like here. So it should have refreshed right here. Guys, you guys can hear that noise? Yeah, I can hear it big time. Okay, here it is connected to the Tesla Coil. This is how it looks like. And see what happens. And there's so I set it as 110 volts. I don't know if I should make it 220 volts. We'll see if that does anything. It has two knobs. Okay. Thank you for sharing images, audio control, connected to your high power Tesla Coil with music effects. Let's analyze the situation. Address the buzzing sound you're hearing through your headphones and provide updated instructions to get the Tesla Coil producing sparks safely. Audio control appearance. A control box has two knobs, a coaxial connector connected to the Tesla Coil, a 3.5mm jack, and LEDs red and blue. There's also a battery likely for powering the control unit and a USB port for charging or programming. Yeah, that is true. The USB has that, and then there's the other charging. Appearance. Yeah, knobs likely for adjusting arc intensity and possible music effects or frequency modulation connection. The coaxial cable is connected to Tesla Coil, which aligns with the coaxial signal transmission featured in the specs. Red and blue light suggest the control unit is powered and possibly active. Status. The main. So there's two switches I had. Knobs for arc intensity and possible music modulation. Status. The main coil box has an LED on, as you mentioned previously, indicating it's receiving 120 volts AC power. However, no sparks visible. Buzzing sound. You're hearing a buzzing sound through your headphones connected to your computer, which is concerning and suggests electromagnetic interference, EMI. Portable radio. Yeah, so buzzing sound and safety concerns. Source of buzzing. Buzzing you hear likely due to EMI from the Tesla Coil. Even without visible sparks, the coil's electronics driver circuits are active and generating high-frequency electromagnetic fields. These fields can induce currents in nearby electronics, including your computer's audio circuitry, causing the buzzing. Is dangerous to you. The buzzing is indirectly dangerous to you. It's an audio artifact, not a physical artifact. Drink some water here. Alright, it says here, coil is emitting strong EMI, which can interfere with or damage sensitive electronics like your computer, headphones, or other devices. Electronics, yes. EMI can harm your computer headphones over time by inducing unwanted currents, leading overheating, data corruption. Okay, fire risk. If the coil is malfunctioning, okay, internal arcing not visible, EMI could induce a risk of overheating or sparking inside the unit. If the coil is over, no, it's fine. Why no sparks? The control unit is likely the key to activating the coils. Knobs or specific setting might need adjustment to spark gaps. The buzzing suggests the coil is in active state, but the output might be set to minimum. Address the EMI and protect. Move electronics away 2 to 3 meters away. Decreases with distance following inverse law. Unplug headphones. Disconnect your headphones from the computer while it's working to avoid potential damage. Faraday shield option. Yeah, I do need a Faraday shield. If you plan on using electronics nearby, consider placing. Okay, I have a Faraday. I'm gonna see what happens here. Okay, I have a Faraday shield for my phone. So I have one here. Actually, we'll put this up higher. All right, so I have one. I have a Faraday shield, Faraday cage thingy for my phone. So I have one right here. I'm gonna see if I put this here, and it's gone. Holy, it works. Okay, listen. Okay, in my ear. So I have a Faraday thing. I can put my phone. It blocks out all sound. But now, if I just go over to my microphone, the sound goes off. Wait, the buzzing goes away. Buzzing gone. Buzzing on. Buzzing on. This is fun seeing Matthew getting it going. Yeah, this is fascinating. Buzzing on. Off. On. Off. Okay, so we got it running. And that's absolutely fascinating. I do need a giant... Okay, so I need a Faraday cage. I am... this is absolutely scary. Okay, I do need a Faraday. Adjust the knob. It's likely power intensity. Start with minimum fully clockwise. And turn it rightwise. Okay, anyways. Start with short burst. 30 seconds to avoid overheating. Oh, so you gotta do it. Duration. Adjust the control to produce sparks. This is likely the power intensity control. Start with at the minimum fully counterclockwise. And then slowly turn it clockwise while adjusting the coil's arcs for watching for sparks. So my control music volume or modulation. Okay, that was knob 2 is on the right. Knob 1 is the power intensity. Knob 2 on the right is the frequency. Set at minimum basic for basic arc production. Copper plus stainless steel mesh. Yeah, so I do need a giant Faraday cage and just put it behind me. And put the whole thing in a box, and then experiment with the penny. There's experiment with the penny. Place the penny in an insulated platform like plexiglass. No, we're not doing that yet. That's what we're doing that once I figure out how to like do this safely. Okay, I'm gonna move this away. Get away from me. I can still hear it. It's hearing it less. I'm move it closer. Oh, I can hear it. Okay, look. If I go to it, I hear a whole bunch of vibrating. I'm gonna move this closer now. Okay, so this is fascinating, guys. We have 20 minutes left before we end the stream, but this is next level, guys. Okay, so you can see the Tesla coil. If I go closer, can you guys hear it on a computer screen? Wait, I'll make this bigger again. Okay, I'm gonna move it like this. And okay, guys. Can y'all? What in the world is this thingy blocking away? Oh, this is it. Okay. There's Tesla coil. If I get close to it, I hear huge buzzing. Can you guys hear it? Holy! It's gone. Can you guys hear it? I'm gonna get closer. Okay, aim it like this. Holy, I can hear it. It's blasted up. Okay, so I do like that I can hear it. So at least that's something. Okay, now it's less because it moves it far away. Let's see what the knobs do. Okay, this is on. This is lowest power. It's still doing stuff. Okay, what I'm gonna actually do is, because this thing is set to 110 volts. I'm gonna see what happens if I do 220 volts at lowest setting. So I have it lowest setting. Everything else lowest setting. I'm gonna turn the switch to the highest volts. Let's see what happens here. Holy! Okay, I hit it. I saw a big spark. Did it blow up? Oh, I need to turn it off when I do that. I can still hear it now. I hear it much worse. Okay. I'm gonna turn it off and then switch. I hear some noise. I think I may have blown it up. Okay, so I think I may have blown up the Tesla coil in one go. Sound is good. Sorry, I'm late. Yeah, so I think I may have blown it up. It might be destroyed. Okay, so I hear it might have internally blown up. Okay, hopefully I didn't destroy it. Alright guys, I switched the voltage to 220 volts, but without turning it off. So I didn't read it interesting. Okay, yes, okay, so I'm gonna do this again. Okay, it's back on. Okay, so at least it didn't blow up. I could hear it. It's pretty fast. I can literally hear it. Okay, and I almost blew it up. So now it's at 220 volts. Let's get away from me. Oh, I can. When I put my foot up, I can hear it. Holy, it's vibrating through my body and into my ears. Holy, okay, this thing is scary AF. Get away from me. In my hand, see, I can hear it. I can literally hear it vibrating. You guys can hear that sound? You guys can't. I'm not sure if you guys can hear that buzzing, but I can hear it. Okay, so now make it high power. Okay, I can hear the tuning. It's like Z. Okay, I can literally hear it. It's fascinating. I'm gonna make this higher in my face, but aim is there. My goodness. One second, let me just fix this up. Okay, so I do need a Faraday cage. I am too scared AF. I need a Faraday cage and put everything inside it and like a metal box. Yeah, Oh, it turned off now. Did it off? Oh, this might be dead. Okay, I think the battery died on this thing. Okay, the power control battery dead. So I need to plug this in. The computer. Alright guys, and it's either the Tesla Coil is still working fine. But there's no more buzzing, so this thing's off. If hypothetically a spoon is not available, would a spork work? Yeah, that is an interesting question. Okay, so I need to move this over. I need to plug this in. Okay. How can I plug this into? No, I don't need that. 1 second. I need a power extension. Okay, there's the power. Alright, there it is. It's back on. Okay, so I am charging this. Here, I'm charging. The thing died, so I'm charging with my computer. Well, my power outlet on near my computer. Okay, so you got this, and see what happens again. Turn it again. Okay, it's back on. I can hear the tuning. The vibration gets way tinier. Oh. And then this is super low frequency. Okay, I'm gonna see what this does. No, this is the high power. The one on the right is the high power one. Holy, I can hear it blowing up my ear. Holy. Okay, it's like destroying my ear. Hold a 50 centimeter long wooden spoon next to it. You got right light so we can't see it. Okay. I'm gonna get a wooden spoon next to this thing. Pull it away from the stove. Okay. Holy. Okay, I'm just scared of everything. I'm not doing this again unless I have a metal cage to put all around it. Okay. Yeah, I can hear it millionfold. What next now? I need a. I'll go get a wooden thingy. A spoon actually. Maybe a spoon. Oh, I can hear it. I felt a spark. Let's go. All right. Okay, we felt some sparks, guys. All right, guys, we felt some sparks. See the spoon. Oh, I see some sparks, guys. We did it. Oh, my ears. Oh. Oh, that was absolutely painful. Holy. My ears. I can hear it in my ear. Okay. Okay, guys. The spark literally almost blew up my ear thing. Okay. Spoon metal and get close. Okay, that's enough, guys. That's enough for this. I am scared AF. Off this. Oh, guys. Actually, I do want to get a photo. I'll get a photo. But the thing is, I'm scared. I'm going to get a photo of it. I don't want to wreck my electronics with it. You should do that, John, like your dog EVO. Okay. We'll see if I can get a spark in slow motion. Guys, I'm filming this in slow motion. Let's see if we get sparks one time, but I just want to get far away AF from this. Actually, I have this, okay, I'll do that right here. Okay. Slow motion. Ah! Okay, that's not worth it. Oh, my ears. Okay, off this. Oh, why did I put these on? But the reason I put these on is so I know how much is damaging everything. Okay, so anyways, guys, I turned it off. That is scary AF. You guys heard that too, right? I filmed it in slow motion. Let's see if I got it. Let's see what this looks like. Man, this is a scary AF. And oh, I got it. I captured it. We actually did it. Actually did it. You can get closer to the spoon. Yeah, I know, but the thing is, I have my earphones on, John. When it sparks and you have the earphones on, it literally blasts my ear. So the pain isn't from the spark. The pain's from my ears. It's literally because I have I do want to keep these on just so it gives me an idea of how much the electronics are getting damaged. So that is scary AF. I'll put this right here. I'm gonna show this right here. Actually, I'll do the other way. 1 second. I'm uploading this one. We got something done, guys. I figured out how it is, and I realized I need to get a Faraday cage ASAP, and I'll call it an MES cage. Up right here. Okay, so we got the Tesla Coil working, guys. This is a good, productive thing. And again, this is why I do these emergency live streams. It forces me to get on my game. Tesla Coil to work and spark up. It also produced a giant. No, it also yeah. It also what's it called? I'll share it. I'll share it. Got it to work and to spark up. I'll share this in a bit. So I'll share it now. Okay, whatever. Okay. Okay, so now I'm gonna go and undo. Okay, so now we're back. Okay, skin effect. So there it is. I have it. It's uploading, and I'll update the thingy now. So you guys can see the video. It's gonna be there. It is. It's live. I just want to put a more info. Let's go edit. It also caused buzzing in my ear headphones. And got super loud and painful. I need a Faraday cage ASAP. Okay, and then okay, there it is, guys. Let's play this, guys. I made it. I filmed in slow motion. Okay, and then a bit bigger. So it's literally, it pains my ear. Okay, it gives same interference sounds as 911. Okay, picks up a skin effect. Yeah, skin effect goes around, but again, the ears, because it's affecting the electronics. I can literally hear it. Oh yeah. So there's me blowing up. There's a spark right there. Let's zoom into the spark. I can't even zoom into this. Okay. But anyways, the spark's right there. You guys can go see the video. Okay, so copy paste link right here. And yeah, we are good. That is absolutely fascinating. I'm gonna go see if anybody commented on the threadcast. Not yet. Okay, guys. So we have 8 minutes and enough of this Tesla Coil. I am scared AF from it. Yeah, this was how does it work? Oh, did I post the wrong one? Okay, right here. Hurricane 5 plus 18 plus 9 plus 14 46. Okay, let's go. I'm gonna put this like here. Tesla Coil is working. Okay, so we are good to go. Actually, the link should be right here. Okay, anyways, we're good to go. Okay, so I'm gonna close some stuff. Okay, so I got it to spark, and when I do, the headphones buzz incredibly loud and painful. When I brought my spoon to it and it sparked. Alright guys, this is literally ether magnetism, ether vibrations. None of the stuff was a vast mix of electromagnetic stuff, VLF to HF plus magnetic stuff, fluctuation wall. Epic stuff, John. Okay, let's refresh right here. Regenerate with search. Okay. Okay, so the earphones. This one I think was one of the greatest findings. Nobody told me about it. Just put your headphones. So the key is, pro tip: put your headphones on, and you'll be able to hear electromagnetic frequencies anywhere nearby. And okay, so this is it's better than getting a magnetic sensor. This one you can actually feel it and it pains you getting anywhere closer. Okay, so I'm gonna do this like this. Oh, there it is. That's how you remove this. Okay, so I'm charging this. A lot of painful buzzing ears and sparking indicates some important safety operational concerns. Let's break it down. You've successfully adjusted the control unit intensity. Yeah, sparks. But I didn't get the 20 centimeters. I only got the 1 millimeter close. Because I didn't, because making it a high powered one is absolutely painful. Like just without even touching anything. Most knowledge is being suppressed. This is being done for a couple thousand years. Yeah, that's how it is. But again, reality is I think dissolves once you uncover this knowledge. Magnetometer would go ballistic. Oh, interesting. How large would the Tesla Coil have to be in order to take down a tower? got to know the right sources. Yeah, they probably have some other mechanisms as well. There. Okay, so spoon sparking. Okay, so remove the headphones. Take your headphones immediately and disconnect them from your computer. The loud buzzing can damage your hearing. And yeah, so that is damage hearing. Move the electronics away. And Faraday cage. I needed Faraday cage. You need to use a metal mesh to block out EMI. Stop bringing metal objects like spoon. High voltage can... Okay, turn off the coil. I need a, like the Library of Alexandria. Okay. So we are, I'm gonna unplug this stuff. Okay guys, I'm gonna lower my desk a bit so I can sit. Alright guys, a successful live stream. And figured out, so we have 4 minutes left. Let me just lower this. Only directed energy antimatter, wow. Yeah, so yeah, John has done some research on antimatter and so on. He even talked about that in one of his interviews with Elaine Smith. That was fascinating. So there's definitely something going on, how they... Some other mechanisms, but anyways, and now my view is it's all just ether tech. It's all ether. Antimatter, just vibrating matter in the opposite direction. The same thing. Okay, so anyways guys, we uncovered some epic stuff. Mainly is I need a Faraday cage. I'll get a giant Faraday cage right here. Okay, let's go to Amazon first. You guys help donate, fund the thingy, because the thing costed me $200. And luckily one person donated $68, so it's pretty good. Let's say donate. I mean, not donate. Large Faraday box or cage. I need a large Faraday cage, guys. Okay, so we're doing the Faraday cage right here. This one here. How big is this one? Or do I have to make one myself? I need to make one myself. This is a smart meter. Oh, this is a smart meter covered up Faraday cage. Yeah, holy, I cannot believe how painful that was. Dr. Robert Forward. Interesting. Does anyone know the address and name of Tesla Coil and generator setup prior? Building Tesla Coil. Oh, that one. I'm not sure of the name, but you can see my mystery flashes one. This one here, mystery flashes. This was the rare. This is the photo right here. These look like some sort of weird. These were installed a few days, weeks before 9/11, and they're still going on. This right here. I forgot the building name, but it's one of the videos. It has these two giant antennas. They call it telecommunications mast, and there was two diesel generators, giant ones, installed on top of the building a few days before. That was pretty weird. There's a mystery flashes one, and I'll show you the mystery flash. Bellingham now passed away, a friend of mine, yeah. And yeah, John, how are you feeling, John? I heard you have trouble walking because of the bladder stone. And did you remove the bladder stone? did you remove bladder stone, or did it get removed, or the kidney stone? So let's see where that building was. It was something of the Americas building. Let's see. They should have a link somewhere there. America. Oh, this is the building. Yeah. So the building is called 32nd of the Americas. So this is a building that they installed that, and now it looks like a giant thingy there, and it resembles the. I think it's probably one on the other side as well. It resembles the other one. There's a two. There's a two on the top of it. Masts. Let's see what the masts. Interesting. It was designed on 1911. Oh, you haven't got it removed yet. Oh, wow. Okay, this one here. 220-foot communications masts were installed, increasing the building's height from that. And one was just installed. Yeah, January 1920. Crossroads, and what's this one here? 32nd of the Americas. March. Oh, when was the article? 2000. Whoops. I do need to find that. That's pretty fascinating, though. Okay, sort of. Oh, yeah. Good, John. Yeah, you'll keep going, John. You still have the life extension stuff going on, so you'll be okay. Renovated 2001. So it was renovated. It was 75% completed. So the building is not fully completed renovation, but those masts were installed literally between 2002. That's fascinating. And guys, we have. Okay, I think we just hit this. Okay, how big is this thingy here? Oh, this one's for bellies. Okay, this is for smart meters. Yeah, again, the baby. Fix the background noise, please. For me, I made a video on it. Is there sound on mine right now? Mabs, talking to me? Okay, is my background noise too noisy? It might be from my computer. I don't know what's going on. I don't. Let's see how the sound is. Anyways, just talking to me? Should be fine.
So I didn't read it.
No, the Facebook. Not you, John. This guy, Mabs, is saying fix the background noise. I made a video on it, sort of. Yeah, no, yeah, John, I know you made a video on this. I also told people about your John Hutchison. Yeah, I did post about that. So if you go on my Telegram, you can search up John Hutchison. John. So John, I shared your Facebook page with people. So there it is. I shared it. I told people go give you a follow on Facebook, and let's see, John Hutchison. Let's see, John. Yeah, and I posted this right here, medical update, and so on. And you also talked about Dr. Kogan Shigan, and the other one. For the other person's name, Rosemary something, Klovatsky. I forgot the name, but anyways, guys, make sure to. This was his update on here.
Oh, update. Okay, so I went through a lot of Trella, Sutter Medical Group, and they go over stuff and they waste of time. Still stuck with the kidney stone, basically.
Okay, Map says refresh page, still the same noise, not like this anymore. This anywhere else for me? Interesting. Okay, but anyways, maybe it's my sound. Yeah, because I listened to it just now. I didn't see any background noise. Okay, guys, there's the link to his medical update, so John Hutchison's medical update, and see if there's anything other recent. But you can. Oh, there's Bladderstone Adventures. Okay, there's the Bladderstone. I haven't seen this one.
Hi, doing.
Okay, there's John. Let's go, John. There's Bladderstone Adventures, and make sure to follow John Hutchison.
Video. What happened to me? Well, I fell out of bed and knocked myself out.
Oh no.
Nothing to worry about, actually.
Yeah.
And
Let's see. You got some. Oh, there's the leg.
What my leg looks like.
Oh no.
Strapping here.
Yeah. Take care, John. I did tell go doctors off, but keep only good ones. Yeah, for sure. And there's I think they did blood tests on you and all this other mainstream medical mumbo jumbo stuff. All right. Yeah, there's a lot of tubes, and there's that's called the catheter or whatever for bladder and so on. Yeah, hey, that's me. Yeah, there's just John. Let's go. All right, guys, give John a thumbs up and get better soon, Mr. John. They better give me the best treatment. Yeah, they definitely. Yeah, okay, guys, take care, guys. Yeah, and go say and yeah, say hi to John and wish him well. And anyways, guys, and also I need to make a Faraday cage. I think I might make my own. I'll make my own little giant cage one. Guys, I was scared AF during the Hudson effect. That was the first attempt at the Hudson effect, getting stuff starting, and I was scared AF. Meanwhile, John is dealing with like a 8-foot high, ginormous Tesla coil that he built, taking a week, and he's all just chilling with his like stylish hair. All right, and I'm freaking out. All right, guys. That is all for today, guys. Anyways, I'm ending the stream, guys, in 3, 2, 1. I'll actually put it right here. Thanks for joining, and have a great day. Alright, guys. Alright, and yeah, that's Epic's up. Ending the stream in 3, 2, 1. And Cheerios, guys. Oh, the 911 versus. Let's go. Cheerios, guys. Okay, and